why you shouldn't take osmoregulation for granted. Your life literally depends on it. Okay, so today we'll be talking about osmoregulation, and specifically the loop of Henle found in the nephrons. So the loop of Henle acts as a countercurrent multiplier, where it's got a descending limb and ascending limb, and the liquids are flowing in opposite direction parallel to each other to allow the most efficient way to exchange substances. The loop of Henle is responsible for reabsorbing water once the filtrate gets to the collecting duct. So let's start. The filtrate that arrives from the proximal convoluted tubule here at the top, where the cortex is, has two things happening to it as it goes further down the descending limb of the loop of Henle. The first thing is that you've got salts being added or diffused into the descending limb, and then you've got water being removed by osmosis. That water goes into the medullary tissue and then eventually gets removed into the blood vessels. As you can imagine, that filtrate is then going to have a very low water potential by the time it gets to the bottom of that hairpin. As the filtrate then starts its journey back up the ascending limb, two other things also happens here. We've got the walls being completely impermeable to water, which means water cannot enter. More importantly, water cannot exit. And you've also got salts being actively transported out, which are the salts that were initially put into the descending limb, which then means that the water potential of that filtrate starts to increase again, so that by the time we get through the distal convoluted tubule to the collecting duct, that filtrate has a high water potential again in comparison to the medullary tissue surrounding it, so that we can reabsorb water should we need to. So if you enjoyed this summary video, give us a like and a follow, and check out part 2 where we'll go through a question together.